ISIS, the International Solar Energy Society, and today we are very happy to bring to you a webinar by the IEA SHC Solar Academy on the topic of making low carbon district heat a reality in the UK. My name is Arabella, I'm with the team at ISIS, and I'm going to spend a few minutes to get us started and to introduce you into ISIS and the work we do. So ISIS, who are we? The International Solar Energy Society, ISIS, is a non-profit UN accredited membership NGO, and we've been founded in 1954, and we've been accredited with the UN since 1992. ISIS has a diverse range of members from countries all around the world, and our vision and mission is 100% renewable energy for all, used efficiently and wisely. To achieve this vision, we have some key activities, such as our biannual congresses taking place somewhere all around the world. For example, the ISIS Solar World Congress, which will be happening next year in 2025. And we've already announced the venue for that. It's going to be in Fortaleza in Brazil, as well as this year's Eurosun 2024, which is coming up this August. And you will be hearing a bit more about that later on. We also have two key publications to share about solar research that's being done. One is the quite established Solar Energy Journal, which many of you will know, and which has been in publication since 1957. And then quite recently, we added Solar Energy Advances to our portfolio. That journal has started in 2021, and it is our first fully open access publication. We also conduct webinars, as the one today, as well as different education initiatives, both online and offline. Additionally, we also share about solar via our infographics, and then also again with our Solar Energy Museum, also something that you will hear more about at the end of the webinar. Now, because I know that everybody's eager to get started, for the Q&A session of this webinar, please type in your questions anytime throughout the webinar. Keep your questions short and precise to help out our moderators, and you can use the chat box to send in your question. Now, on the topic of moderators, it's my great pleasure to introduce to you not one, but two of them. First off, we've got George Bennett. He's one of the co-moderators for today, and he's the lead technical energy advisor at the Department for Energy Security Net Zero in the UK. And then secondly, we have also with us Robin. Robin is the UK representative and current chair of the IEA TCP on district heating and cooling. So together, the two of them will take us through the webinar, and I'm happy to hand over.
Thanks, Arabella. Yes, so this is a bit of a double act. I hope it all works nice and smoothly. I'm just trying to get myself so I can share my screen. Yes, because I have some slides to show you. See your screen. So this is a piece of work that is, oh, showing myself. It's not very professional, is it?
It's all right, you could go ahead. We can see the presentation.
You can see the presentation, great.
Yes,
so
yes.
Yeah, so this is, it's a double act because I am the UK representative into the Solar Heating and Cooling TCP, part of the IEA, which I'll explain in a second. And Robin is the equivalent person looking after the district heating. So, you know, we're looking to, this whole webinar is designed to bring together technical expertise, which is looking at solar heating in district heating. So it's the coming together of two fantastic low carbon technologies with a view to giving people an insight into what is the potential in the UK. So these are learnings from abroad, from international, and looking into how we can use them in the UK. So the Solar Heating and Cooling TCP is as old as I am. 1977 it was established. It has a wide range of countries involved from all over Europe, North America, Australasia, etc. 19 countries, 200 experts, a very large number of fantastically interesting projects that we run, which look at solar heating, solar cooling, lighting, really a large number of solar applications which are not PV related essentially, but are heat related. There there's a number of them ongoing still, including one on district heat. If you're interested in anything more to do with the solar heating and cooling, then you should check out whether your country is a member. The UK is a member, and I'm the representative for that. So if you have anything, if you're from the UK, please do reach out to me and we can talk about what might be of interest to you. Or if your country is not a member, it's also possible to lobby them to join. It is really not a huge amount of effort or money to join, and it does give you an access to a large number of experts and information. We put on this Solar Academy together with ISIS. So this is a great platform for sharing all the expertise and knowledge that comes out of the TCP, where there's a lot of technical research from around the world, and it puts together training materials, case studies, fact sheets, a huge amount of information, and it is all put out quarterly together with ISIS, and all the videos are available on YouTube. So if any of your colleagues missed this one, for example, please share the YouTube link with them and they can look at their leisure. And it is possible also to do on-site training, to have on-site training through the Solar Academy. It's not just virtual web-based stuff. It takes a bit more organization, but it is also possible. All of our information is on our website, including all the publications from all of our projects and research, and we are, of course, very active, as always, on LinkedIn, Twitter, X, YouTube, etc. Any questions in the meantime, best addressed to the Secretariat. The email address is there at the bottom, secretariat@iea-shc.org. And one final plug is for the Solar Heat Worldwide document that comes out every year. This is really a fantastic state of the union type report on where solar heating is in terms of statistics, how much installed capacity there is in the different countries, what it's being used for. It's really a fantastic resource, and a lot of effort and data goes into it from all of our members. Plus our semi-annual newsletter, which is also a great way to get your finger on the pulse of what's happening in solar heating. That's it from me. I will hand over to Robin to give you the view on district heating. I'll just stop sharing my screen. Right, Araba's done it for me. And hand over to Robin.
Thank you very much, George. Just trying to draw down my screen. There we are. Go to the correct slide to begin. So if I could just start by thanking George and colleagues from Solar Heating and Cooling for inviting me along, and colleagues from the District Heating and Cooling Agreements. I think it's a really great thing to see the opportunities and the potential for the joining of these technologies in seeking out sustainable future. So I'm going to next try to go to my next slide, which is not working. Not quite sure why.
Robin, can you use your keyboard?
Yes, I'm just trying to. There we are. It's working.
Good, thanks.
So, like the Solar Heating and Cooling program, we're very much a program with an international reach, and you know what we're trying to do, what our mission is to try to reduce cost and improve performance of what we regard as this important technology. And again, as you saw with solar heating and cooling stretching across the continents, we also, from North America, many European countries, out to Asia, where South Korea and China are members. And we have a total of 17 member countries. So what we do, we've got a current work plan, 5-year work plan, looking at several key issues: improving the business case, looking, of course, at decarbonisation, and in the context of district heating, that really aligns with temperature reduction very largely. And that actually melds into the third of the bullet points, because we can integrate more easily more renewable energy sources for longer if we are managing to operate at the lower temperatures. We're also looking at how the energy vectors in the future will progressively join together, so hybrid energy networks. And of course, there's a very important balancing function for district heating networks for the future smart electricity grid. In that context, I think right across the piece, digitalization is a really important area, right across the technologies. And lastly, of course, the district heating infrastructure itself, the pipes and controls and so on, is very much on our radar. We have two types of project. I'll say this very quickly because we obviously want to get on with the main presentations, but I think it's important for me to say that the cost share projects are chosen by competitive bidding. So that means that folk who are listening in right now who would wish to try to bid into future programs, just please look out at our website for when we undertake our next competitive bidding round, which will be probably sometime in 2025. So it's not this year, but coming along surprisingly quickly. Time flies. In contrast, our task share projects are shared projects where any potentially any organization within one of our member countries can join with other such organizations in other countries to jointly take forward a project area that's of mutual interest. So that we don't provide resource for. The cost share, fully funded, we provide the resource for that. So just quite quickly want to show you, I'm not going to read through all of these, but these are the cost share projects that have recently completed, for which there are project reports available at our website, freely available for all. So, you know, some of the themes you see there I've already spoken about, transitioning to low temperature, looking at future business models, integrating and making use of artificial intelligence, and so on. And then just to tell you what's going on within the cost share projects right now that have just started. So here we see quite a lot of focus on the finances, getting a sustainable future model. Also very important words cropping up there like flexibility and integration, again, of low-grade sources, which, by the way, as well as renewables, includes waste heat that's already available within our communities. So, you know, for example, from data centers. And then to just show you what we're doing in terms of the task share projects. Whereas our cost share projects tend to be very focused, these allow a bit of a wider framework. And so some of the themes, of course, are just the same. You see right at the top, low temperature district heating again, and hybrid energy networks, which I've mentioned, digitalization, and integration of renewables, which of course brings us to today's webinar. And then some task shares which are just getting going, looking, well, first of all, let me say that the digitalization theme is important enough for us to carry on with a second task share on that topic that's just being developed. But we also see there, for example, the matching between industry and district heating and cooling, the use, for example, of industrial waste heat, and at the top, how fundamentally we want to see the maximum lifetime of the actual pipe infrastructure. At our website, you'll find full reports for all the completed projects, as I mentioned, information of what's going on right now, a bunch of webinars, including, as I understand, this one is being recorded, so we'll hopefully add this one as well, but there are other topics there too to take a look at. We have a guide to information by topic and links to other sources that we feel you might find useful. So I'm very happy now to hand back. So I will stop sharing my screen, and like you, I'll be listening with interest to each of the presentations that are just about to come along.
All right, then we are on to our first speaker, and I believe, George, you're gonna introduce us to him?
Yes, I'll introduce Andre. Andre has a very interesting presentation insight coming up about resource analysis, how the comprehensive technology assessment for district heating networks, including solar. I mean, obviously, like all of our speakers, a very illustrious background. I won't embarrass them by reading out their achievements, but suffice to say, an expert that we're very happy has donated his time and expertise to come and talk to us today. Without further ado, Andre, I'll hand over to you.
Thank you, George. Hello, everyone. Happy to be here today. I'm trying to now transfer my screen. Let's see if that works flawlessly. So I can't click that. So you should see a screen in standard mode, and now hopefully in presentation mode.
Can you see me? Yes, we can.
Am I looking at the camera? Because I don't see it at the moment.
We don't see your beautiful face, unfortunately.
You don't see me? Okay, that's weird.
Yeah, there we go. I can see him.
Okay.
Right on top.
Classic solutions, switch it off and on again. So technology is reliable in some ways. So yeah, 50 minutes I have today to present to you resource exergy analysis. I abbreviate it with RIA, a key to comprehensive technology assessment, including solar heat networks. I'm Andre Jensch, as I said, IEA program manager, among other things. And as such, I present today to you this rather novel approach to analysis and selecting systems. So I'd like to start with an image. Climate protection without sound assessment methods is like driving a car with a painted windscreen. Accidents are inevitable. So just imagine somebody painted a straight road onto your windscreen and you think actually that's the real road. You drive confidently on what you see. Unfortunately, the real road is winding and you end up in an accident. This is essentially what can easily happen when analysis is done wrong. So you get numbers on CO2 savings, on efficiency, but the assessment method was not appropriate or incomprehensive, and you end up somewhere else than where you wanted to go. And that again leads to climate protection without a realistic and comprehensive assessment of technologies, leads to greenwashing. So you consider technologies green that actually aren't the best solutions, invest in them. The investments can be considered not very good, and that again will lead to more climate change than necessary if the analysis had been done correctly. So why a new evaluation method? Current assessment systems are simply not sufficiently comprehensive. So if you look at primary energy factors, fossil, for example, they are often indistinguishable for renewable energies. PV, solar thermal, hydrogen, wind power, biomass is all almost zero. So essentially they seem to be all the same, but to anyone with an engineering background, this seems rather suspicious because quite obviously they are not. So this factor cannot be used to assess their differences. Primary energy factor total, same here. Renewable energies are hard to distinguish, but also fossil energies are very close to renewable energies. Best example, solar thermal energy is very similar to natural gas. It's just 10% difference. So it's also not very helpful in terms of efficiency, because kind of the feeling among engineers at least is this must be much better than just 10%. The renewable energies obviously should bear the main load of decarbonization. However, there are no guarantee for climate protection, as everybody knows who follows the biomass discussion. So unsustainable biomass, such as palm oil from rainforest clearance, can easily be worse than fossil fuels. So just being renewable doesn't protect the climate. Direct greenhouse gas emissions, yes, they are important. This is the key metric that many are trying to decrease, to minimize, but unfortunately they are not sufficient on their own, simply because indirect emissions due to wastefulness are not considered. How that comes to pass, I'll explain a bit later. I asked the organizers to include the word exergy in the title. I know it's a bit confusing, maybe a bit unsettling, so I hope I can explain it in a simple way. So what is exergy? Everything starts with energy that you should be familiar with, but energy is not the same as energy. It has different forms, power, heat. And if that is considered, one can say energy has a certain quality. And the product of energy and energy quality can be considered exergy. So what is now this energy quality? So if you look at an energy flow and its potential together with the environment to produce electrical power, that's essentially the energy quality. So if you can produce 100%, if you can convert 100% of the energy you're looking at into electricity, then it's 100% electricity, mechanical work, or even fuels, because it's an ideal value. So if the machine were perfect, what is the physical potential of it? With heat, even with an ideal machine, it depends very much on temperature, how much electricity could be generated. And that leads to a couple of insights. For example, energy is only converted, exergy is consumed. So when people are talking about energy consumption, it's physically not totally correct, because energy is just transformed from one form to another. Easily seen in gas boilers, you put in fuel energy, it becomes high temperature or moderate temperature heat, and then it becomes ambient heat once it leaves the building through the envelope. Exergy is the product of energy and energy quality, and it can be understood as valuable energy. So power equivalent, but let's say just valuable energy. An analogy can maybe illustrate this a bit further. So energy analysis is like accounting with coins. So 1 kilowatt hour equals 1 kilowatt hour, whether it's gas, whether it's power, whether it's heat, it's all 1 kilowatt hour. And it seems to be all the same. As I said, the energy quality is not considered, and accounting with coins is also not very helpful when doing bookkeeping. So exergy analysis is kind of the upgrade, accounting with money. So now there is a value printed on these coins that is also considered in the accounting. A high value energy is traded for many more coins of low value energy, and that then can be considered a fair trade. From the definition of exergy, a bit expansion, resource exergy. So what are resources? Energy and raw materials from the environment. They can be measured in exergy. Why is this important? Because sometimes balance boundaries are set in a not very helpful way. And why resources? Because resources, they are storable. That means if we don't use them today, we can use them tomorrow. Therefore, being frugal with them makes sense. Solar energy, on the other hand, is fluctuating. Therefore, while it makes total sense to make most out of the solar energy for cross-technology comparison, it cannot be the primary energy or the resource, because otherwise we would have to consider the solar energy that went into biomass or into natural gas or into other fossil fuels as the primary energy if we wanted to do a fair comparison, to avoid that kind of, let's say, ambitious project. The approach to resources was taken, so it's an energy form that is directly storable in the form you are looking at. That means for solar, PV panels produce the storable resource electricity. Solar thermal produces the storable resource high temperature heat, and that is essentially the input in the system and in the comparison. So this resource exergy analysis is a method that considers exergy and sets consistent balance boundaries. It integrates energy and energy quality. That means the first and second law of thermodynamics, and it considers only directly storable energy flows as resources. The goal is to help minimize the waste of resources. The advantage here is it has been an application for over a decade in research and practice. It has been used in German government-funded projects or internationally, and it enables a realistic comparison of district heating and cooling systems with individual solutions. That's where it's essentially quite crucial to use such a method that is exergy-based instead of an energy-based method, because otherwise the benefits of district heating and cooling cannot be comprehensively assessed. How can this resource exergy analysis now help reduce greenhouse gas emissions? Sounds first a bit weird. I was also a bit surprised when this insight came to me, but let me show you what I was thinking when I came up with that claim. So energy is still partly fossil until the foreseeable future. And while everybody says, yeah, electricity is going to be green tomorrow, I'm really wondering what happens if electrification of industry, mobility, and hydrogen production is going as planned, because these are huge loads that are much higher than the current electricity load in some cases. So there will be fossil energy in the foreseeable future, in the next decade at least, in most energy systems. And low greenhouse gas energy, such as renewables, will be expanded as fast as the policy allows and used as much as the grids allow. So the question is, what happens when resources are wasted? So if resources are wasted, it increases the demand for energy resources, which are potentially high carbon due to the low carbon sources being already used. That in turn means that indirect greenhouse gas emissions are caused that are difficult to determine, because that would mean to know exactly what system is responsible for what additional emission. On the other hand, it's also smart to save resources in terms of bringing operation costs down. So resource exergy analysis makes waste of resources transparent and helps to minimize wastefulness and associated indirect emissions. Here now is an example that illustrates the differences simply by analysis methodology. I've talked about the lack of suitability of energy analysis for example, solar thermal. As you can see here, the black and gray bars is primary energy fossil and primary energy total. They both are very similar for PV and solar thermal. So it would seem as if solar thermal is essentially almost like PV. But looking at resource exergy, we see that it's completely different. It is 3 times better suited than PV for direct building heating, because we use much less resources per unit of heat delivered. One can argue CO2 emissions would also show a small difference, but they are very small anyway. So if any savings are calculated, the savings by employing either PV or solar thermal in terms of CO2 are almost 100% in both cases. And also we would miss the impact on indirect emissions just going for CO2 emissions. Primary energy analysis, on the other hand, shows an unrealistic picture, as we've seen, since it doesn't consider energy quality. So how can resource exergy analysis support solar thermal networks? So support the argumentation for such networks by quantifying its advantages comprehensively, show that these networks already provide a green and resource saving solution that cannot be provided by any type of electrification that uses the grid mix until it's completely carbon free. And when that is happening, we don't know, especially in winter during heating season. It helps to consider the solar thermal networks in comparison with other solutions, district heating solutions and other individual solutions, and it allows a quality control of analysis results. As I already said, they can be quite wrong without anybody noticing because nothing breaks down if somebody comes up with a misleading CO2 number or primary energy analysis result. So it helps to mitigate the risk of greenwashing and costly mistakes. How can this now help with well-informed decision-making? Now here is an example of three indicators that can be used to comprehensively do screening of various technology variants of various transformation pathways. One is resource consumption, resource exergy consumption. One is greenhouse gas emission into CO2 equivalents, and one obviously is costs. Ideally life cycle costs, but for the first step, maybe costs of energy would be sufficient, simply because if the costs of energy are lower than the reference case, this is a technology that can essentially pay back in time. The traffic light system is a way to make these, to focus on the savings, to help decision makers see the picture more clearly, because everybody knows the savings idea from when you go shopping. So it's always says 30% off, 40% off, etc. And it gives you an understanding of how much you save. It's the same here. Green means more than 1/3 of the indicator. The indicator is 1/3 lower than the reference case. Yellow, it's lower, and red, it's worse. So the reference can be set freely, and that allows a fair comparison of various alternatives. This is just an example. There is a way to visualize this resource exergy analysis. I can't go into detail now because I don't have the time, just so that you've seen it. And what can authorities do? Well, they can inform their technical staff of the calculation guideline that AGFW, the program manager, put forward, that contains all explanations, equations, and LCA data. You can get accustomed to resource exergy as a key metric for savings and efficiency. Require such calculations for transformation plans, at least as a quality check, because, as I said, it can be easily wrong without anybody noticing, especially when heating and cooling included, especially when solar is included, because for solar thermal, there's also one issue with the LCA analysis, that the solar energy is considered primary energy, while it cannot be saved by not using it. So I think that might be a problem that also resource exergy analysis can solve. If you're interested in this methodology, contact me for more information on how to apply it most easily. I'd also like to end with a small metaphor. Heat and transformation plans without scientific validation are like a car without official approval. Can't rely on them. And since countries, municipalities place a lot of money based on these plans, I think it's worth doing a double check, ideally doing something like resource exergy analysis. So thank you very much. If you have any question on how to apply this or learn more about exergy passes for faster decision making, simply contact me and I'll be happy to answer your questions after the following sessions. Thank you very much.
Thank you, Andre. That was very interesting from my point of view. The amount of discussions I've had comparing different technologies on the basis of primary energy, carbon, etc., and every different metric gives you a slightly different answer. So it's very useful to have this type of discussion about the exergy dimension. The next speaker is Magda, working in Stuttgart, where I used to live in my previous life. And Magda is going to give us a super interesting insight into the current market status of solar district heating systems in Germany. So hopefully lots of interesting insights that we can learn from in the UK to boost our own nascent solar heating and district cooling industry. So without further ado, I will hand over to Magda. Thank you very much.
Hello, everybody. Thank you for the introduction. I will share my screen. One moment. I hope you can see it now.
Yes, all clear.
Okay, fine. So I will give a presentation about the current market status of solar district heating systems in Germany and government support measures. And for me, I'm also involved in IEA SHC task 68, where it's about efficient solar district heating. Solites is a research institute in Stuttgart, and we are focusing on the fields of solar district heating, as you can see here in my presentation, and also geothermal energy, shallow geothermal, and heat storages, simulation work for overall systems. And our goal is to have or to create systems with minimized emissions and which are good for the future and sustainable. So what is efficient solar district heating? We have here one system as an example, so you can see what components are inside. With solar thermal collectors, you can have a big field of solar thermal collectors and can directly give it into a district heating system. And this is a very cost-effective and flexible heat delivery. So here you have, for example, a short-term or a seasonal heat storage and other components, of course, because solar thermal is not the only heat source. So you need some maybe waste heat or other excess power or other components with renewable heat as renewable heat sources. Then here in the district heating systems, there are the demand in the buildings, and you have a heating center in the middle with maybe more system components. I have some examples so you can see how it looks like in reality. Here the solar heat grid in Ludwigsburg. You see here the construction works. It's a simple method of construction with ramp profiles in the ground. It's very fast and cost efficient. And on the right side, you see the picture of the installed collector field near the city. So here you have a direct delivery of heat to the city's district heating network. And here's one. The example is that you have here the field shared from two grounds. So in the middle is the street, and here is one. The neighbor city has this field, and this is the field of Ludwigsburg. So it was a very, it was a, I'm missing the word, but it was not so easy to get the permission to build it because it's divided into two areas of cities. Another example how solar district heating can be installed is on roofs, here on apartment buildings. And you have here the a single collector field, a smaller one on the roof, and it is it feeds in decentralized in the district heating. So if you need the whole heat in the building, it's used there, and if there's more heat than the building needs, it's shared with the district heating network. So this is an example for a decentralized feed-in of solar heat. How is the market status in Germany? We have 55 plants in operation. You see it in the map here. And these are very different kinds of solar district heating plants, from bioenergy villages with heat from wood and solar, often also organized in an energy community, or smaller towns, also urban solar district heating in bigger cities, and also collectors on buildings. Here, what I didn't say before, collectors on buildings are more expensive to install than on the on larger areas on the ground. There's a lot of information materials for various target groups. Here you can find it. It's unfortunately it's in German, but maybe you find something useful here. We have also in the map the plants which are in realization or in the planning process. It's the gray bubbles. So we have 9 plants with more than 100,000 square meters are in the planning process. And there are some more in preparation. It's 70 plants which we know are in preparation, and it's more than, or it's almost 400,000 square meters. So there's a big, a big development in the German market. So what are the success factors for solar district heating in Germany? We have supporting laws and their ongoing development, some funding programs for different renewable heat technologies, and also funding in R&D activities in long-term national funding programs. So it's not only the funding for investments, but also for R&D activities. What is also important is finding areas, of course, to install the solar thermal plants near the heat demand. Also best practice examples which can be visited and encourage possible investors, and know-how transfer, trainings, information materials, and tools for the target groups, so that people know what are the possibilities and how to do it. Supporting laws. It's very important to start now with decarbonization of district heating, because we have the decisions about climate neutral building stock by 2045 in Germany. And we all know if what we install now will last until maybe 2050 or more. So it's important to start now and to install the plants which are sustainable for the future. In Germany, we have a law on local heat planning since 2023, and there it's necessary for all cities to make suggestions for energetic refurbishment of buildings, and also to plan areas for district heating and for single house solutions. So they need to plan which areas are used for district heating and which are not. And there's a new national law, the Building Energy Act. So every new heating system of houses that are not connected to district heating has to reach a minimum of 65% of renewable share or to get connected to district heating. And the district heating networks need to, there's necessary to make a transition plan for the total decarbonization of the heat demand by 2045. And not only the plan, but to follow this plan. And also subsidies are provided. So this makes really a lot in the market, that there are these laws which support solar district heating. Also ongoing in Germany, the transition of the EU RED III directive, and there are new laws to support large collector areas and other renewable heat sources are made, and building permits for the plants are made faster and easier in the future. For the funding of solar district heating, I will not go in detail because it will be explained in the next presentation by Thomas Pauschinger. So, but what I can say, you have for solar district heating stable heat costs of 40 to 70 euro per megawatt hour without funding. And there is the German subsidy program BEW. It's for efficient district heating since 2022. And here it's possible to get funding for 50% of the invest costs. So it's not only for solar district heating, but for different technologies for the renewable heat supply in district heating. What we see in the development of the German SDH market, here you also see once more the different, or you see here the different kinds of solar district heating in red in quarters of cities, and in green in bigger cities, in energy villages in blue, and then the light ones are in preparation. So you have here the collector area on the left side and the amount of plants on the right side. And we see that there is a good development in the market, but there were some stops or not so much development here in 2021, for example, because there 2 years it was the waiting for the new funding scheme BEW, and it was said that it will come, but then it needed more time, and so the market was waiting, and the investors, of course, waited and said, no, I will not invest now, but I will wait for the good funding opportunities. And so the plants which were thought about in 2021, were just installed in 2022 and in 23. And what we also see here, there's often long time needed for building permits of the plants. So this is something we need to work on in Germany to be faster in the permits to realize the plants. What we also see is that the plants get bigger, so there are more. There's more collector area per system installed in the last years, and it will be more. So almost every 1, 2, or 3 years, there's a new biggest solar district heating plant in Germany. Another big point, finding the area. So how much area do you need for your solar district heating plant? And here's a comparison just to get a feeling. To meet 20% of the total annual heat demand for 1,000 households, you need 1 hectare of area for solar heat. And what does it mean? For the collector area, you need more ground area. So for 1 megawatt solar heat capacity, an area of 1,350 square meters are needed on the ground. So you have some buffer zones on the sides, and of course, you need some area because the collectors are placed in a certain difference. So finding areas near the heat demand is very important and a big task in the project development. And it's often a long process. What is important for this? The communication between utilities, investors, and the local authorities. A structured analysis of possible areas, and it's better you have you found more areas than less, so you can use it maybe for another future project. There are some synergies for the areas. So like here in the examples, you can have a good ecology on the areas. So there are new plants growing, the biodiversity will be good on your area. And here, for example, on the right side, you see sheep on this area, so this is also a possibility. One example as a best practice, here for almost fossil-free district heating with 95%. It's a system which is in the real planning process now, and it's very special because here a big heat storage is built in an earth landfill, and so you can store the solar heat, you see it here, seasonally, and so provide it very efficient to the houses. It's a new building area, and with the solar thermal, the heat storage, and shallow geothermal, there is 95% of fossil-free district heating possible. Another plant which is just in the installation process or just installed and will soon be in operation is in Sonnershausen. It's 6,000 square meters of collector area, and it's a new product. It's high vacuum flat plate collectors, and it's very efficient because these high vacuum flat plate collectors can produce temperature with more than 100 degrees. And this is not necessary here. It's normal district heating, but there are a lot of cities in Germany with district heating with more than 100 degrees. And this is something we analyze in the IEA SHC task 68 to find solutions. How is it possible to include solar district heating in or solar thermal in these district heating networks with higher temperatures in an efficient way? If you want to have more information, I can recommend our newsletter or our website. And here are also two other sources in English from IEA SHC task 68, an info package for cities and towns, and a brochure of solar heat for cities. So thank you very much so far, and I'm looking forward to your questions.
Thank you, Magda. That was very useful. Thank you very much. And there are some questions coming, so don't worry. There are a couple of questions already in the chat. It would be very useful when you're putting in your questions. Just to remind you, there is a question opportunity. It'd be great to remind us which speaker you're sort of aiming your question at, rather than making it general, just so we can make sure that we get it to the right person to get you an answer. We have one more speaker. Sadly, as we said at the beginning, we're missing our final speaker, but we do have Thomas. We're staying in Germany. We would have been going to Austria as well, but we're going to have to stay in Germany for now. And Thomas has got another fascinating talk for us about the challenges and opportunities for solar thermal in what is, as we saw from Magda's talk, very rapidly expanding and changing heat network situation in Germany. And he's also going to talk about its district heating and cooling sector. So over to you, Thomas.
Yes, good afternoon, everybody. I'm happy to be here with you. Thanks for the invitation, and I'll try to share my screen as well. Just asking, can you see my screen?
We can see your screen and your desktop, but not any slides yet.
Okay. Okay. Maybe you can send the invitation once more, because it was the wrong screen. Sorry for that.
Perfect. Yes, we see a desktop with your slides in it.
Okay.
Great.
Good. Okay. So I'm glad that Magdalena Berberich gave a quite good overview on the solar district heating. So I can maybe focus a bit more on the policy and market topics of district heating and cooling, because I think if we are successful in developing district heating and cooling, there will be definitely a lot of carbon neutral district heating and also solar thermal district heating coming with that. I would like to give you a bit an insight of what is happening in Germany at the moment in the district heating and cooling sector, and I will then pick up the solar thermal topic at the end again and tell a bit about the viewpoint we have on solar district heating and cooling. So few words about HEFW. We are the district and heating and cooling branch association since more than 50 years. We have around about 700 members, and more than half of them are heat suppliers and companies which are producing heat. We represent more or less 95% of sold heat in Germany. And beside, let's say, advocacy policy topics, we have also a quite large technical department. We are publishing the technical rules for district heating and cooling. We have also an R&D department. So let's say we are really looking that district heating and cooling is implemented in a good quality way in Germany and also other countries, with all the aspects also Robin mentioned before already in his presentation or introduction. My role is that I'm in the R&D sector at HEFW, but I'm also representing HEFW in the state of Baden-Württemberg, and I'm also leading IEA DHC task shared 5 about the integration of renewable into district heating and cooling networks. So I included also this slide, which is about the activity of HFW in the field of solar district heating, because I think it's good for you to see we are active here already since 2009 in more than 10 national and international market introduction projects. So the topic is absolutely not new. We consider solar district heating really as a mature technology ready to use. We also collaborate with all the suppliers of these sectors, and we also have various services for our members. So for example, we have one document how to make tenders of solar district heating plants. We are offering courses, and we have guidelines how to implement this plant, and we are also partner in the project Magdalena mentioned before. So what about the new role of district heating in Germany? I was writing here the headline, never before district heating had such a high significance in Germany, and I really think this is the case. We have a government which is really focusing on the heat sector in this legislation period. So there's a lot of policy, and let's say in this transition of the heating sector, there are two pillar technologies. One is district heating and cooling. That means centralized heat supply. And the other pillar is heat pumps for decentral solutions. We had in the end of 2022, the gas crisis coming with the Ukraine war, and in the same time also the funding program that brought quite some dynamics into the district heating and cooling sector. And as you see here on this slide, we have also an ongoing summit, DHC summit process with the German government, where we really define our common goals. You see them here. We should triplify the numbers of buildings connected until 2045. There shall be more than 100,000 new connections every year, and district heating cooling should be 50% renewable until 2030. And behind that, it's not only, let's say, these agreements, but there's also a process to really work together, government and, let's say, various associations on the obstacles which are there for district heating and cooling. And one was mentioned also by Magdalena is really the improving or shortening this permission processes for all the renewable technologies and district heating networks themselves. So the situation is very positive on one hand. On the other hand, you know, it's enormous investments for the branch and a lot of challenges, because each project you're doing at the local level is quite a challenge. So the starting point you see here, we have about 4,000 networks in Germany with 34,000 kilometers, 50 gigawatt installed, 140 terawatt heat production, which is around about 14% of the building sector. That means this shall increase to 40–45%. And we have over 80% in combined heat and power. So that means it's already very efficient, but it's let's say still only 30% climate neutral heat if we count renewables, if we count waste heat, industrial waste heat use, and waste in generation. And the other 70% are still fossil, and big challenges, of course, to extend district heating and cooling, and at the same time as we decarbonize this production technologies. This is the path which is well investigated in many studies, but it's more or less always the same way to go with some different numbers. You see here in the bottom left of the graph still the fossil, the carbon technologies, they shall really vanish until the end of the decade. Then we have bioenergy and let's say the biogene part of waste incineration, which will remain stable. We see this light green part, which is natural gas, which will remain, let's say, a transition technology until the end of the process. But in the end, in 2045, 2050, this has to become hydrogen or other green gases. We see a big growth of electric district heating in terms of heat pumps and also some electric boilers. And industrial waste heat is also, and geothermal and solar thermal shall also become a relevant part. So this is the transition path, which is on the whole scale and which has to be implemented, of course, according to the situation in each location where you have district heating. We see this 13 terawatt-hour of solar thermal. This corresponds round about to 26 million square meter of solar collectors. That means we need 1 million square meters each year. And if you look at Magdalena's numbers, at the moment there's a growth of 200,000 square meters a year. So it's not so far away, but still there must really happen something significant. In terms of policy, we have quite some lot of legislation. You see also here this text on the left, which is in the agreement of the coalition, which wants to advocate comprehensive municipal heat planning, expansion of heating networks, high proportion of renewable energies in the heating sector. So it was a concrete game of the government, and I think very important was now, let's say, the funding programs, but also the laws, which were just published now recently. And I just want to give you a short insight into these laws. I don't want to go in detail, but I put also some slides at the end of my presentation, so you have it maybe when you receive the presentation. So let's say the roof is, of course, the Climate Protection Act with climate neutrality in 2035, then driven by the Energy Efficiency Directive of the EU. We have the Heat Planning Act, addressing cities and municipalities that they do heat planning. Magdalena also described this already. So heat plans has to be prepared. They give also a certain certainty then to the actors, but also the citizens, where, let's say, the train is running. And it also requires transformation plans to the heat suppliers. So they have to officially make this transformation plans also in accordance with the heat planning. And this was then combined with the Building Energy Act. There, the addressee are the building owners. They have requirements that they have to change to the 65% renewable energies. And the important point is there, one possible option to fulfill the building energy requirements will be district heating and cooling. So if you connect to district heating and cooling, or district heating and cooling is developed in your area, and this is, let's say, with a commitment, then you're fine with all the building requirements. And this, of course, gives also quite a push to the sector. And this was also then, let's say, underpinned with funding programs, both for district heating operators and building owners. And the one for operators is called BEW, which is Bundesförderung effiziente Wärmenetze. And this again was published in 2022, and it was really a game changer because the enterprises have been ready to invest. There are 4 billion euro for 2002 to 26. It seems a lot, but investments are big, and we hope that it will be sufficient. We also see that in this 1.5 year, already 1,300 application has been made, and already around about 700 million euro have been approved. And yeah, the good thing is that it's really a holistic program, financing both, let's say, measures in the district heating network, also extension of district heating networks, but also change of the production capacity to renewables. And just shortly to show you how this works is it's subdivided in let's say 4 modules. The basic idea is as a district heating supplier, you have to first make a plan and a clear picture how you want to decarbonize until 2045. So you have to paint the final pictures, and you have also to show what is your roadmap to this final stage. And then you can take the first slice and plan it in detail. Such a slice is 4 years, and then you make an application to get financing for that. Also, this transformation plan is financed in the module 1, and the module 2 is then the first slice of 4 years. And then you can invest and build, and then at the end of this 4-year period, you can already go to the next step, prepare the next slice, and then make the next application and come to the next investment period. And then there's also module 4 giving operational cost subsidies, and the basic idea is to make renewable district heating and cooling at the same level economical like CHP, combined heat and power, was so far. Okay, and we have quite nice lighthouse projects also coming up with all these initiatives. We have just last year the first river heat pump with 20 megawatt in Mannheim. There's another one in Stuttgart. In Cologne, it's 150 megawatt plant. We have another biggest solar thermal plant also in planning at in Leipzig with 46 megawatt, and really other plants coming up. And it's nice that the branch is recognizing that and really taking this opportunity and planning and doing investments. So just in brief, from our viewpoint, what are challenges and opportunities for solar thermal and all that? Of course, there's a competition also between renewables. The real competitions are, of course, fossils, but anyhow, the enterprises make their choices. And how do they make their choices? They look at the various technologies, how they fit in this complete final pictures in the roadmap. And let's say they look at, of course, ecology aspects, economics, and security of supply. And let's say the environmental aspects of solar thermal have been always perfect and really convincing. Luckily, also economics are today no problem anymore, because competing with other renewable solutions, solar thermal is doing quite well, especially with this funding program. Let's say a bit challenging is still the security of supply, because we have a quite volatile heat source. And this could be solved, of course, with large storages, but yeah, we have some seasonal storages, but let's say they are still for the smaller systems. For the larger systems, they still need to be developed. But also here, the government is really working on a large-scale storage strategy, and we also hope for that. Temperatures of networks are, especially in the larger networks, still high. Can be 110, 120 degrees as supply temperatures. And let's say already reducing at 90, 95 degrees is possible, but it's quite an effort. It's not simple. Luckily, solar thermal can work on these temperatures. The collectors are ready to deliver at, let's say, the summer temperatures of the networks. That's not a problem. We also promote to really check how we can integrate solar thermal at outer areas, remote network areas, how to integrate there. Just imagine if you go to the really central places of the district heating networks where are the power plants, you have high pressures, high temperatures. If you go a bit out remote, there you find more areas where you can put solar collectors, and the conditions are much better for solar thermal. And even from a hydraulic point of view, it's quite good if you have, for example, an extension in an outer area to look at these parts. We think there are really convincing low-hanging fruit, like the combination with biomass, also the combination with biogas and biomethane are quite working well at the moment, because biomethane producers don't want to burn the biomethane anymore. They want to feed it in the gas network, and because this is paid very well. So we should continue harvest and seed this low-hanging fruit. And last not least, areas are still a topic, not only for solar thermal, it's for district heating, future district heating in general. We need areas for putting heating centrals close to the let's say, yeah, urban, not centers, but close to the living areas. And still, I think authorization procedures and things are not yet sufficiently short. There is still some work to be done in these fields, also after all the efforts which have been done in the last years. So I come to my conclusions. We see at the moment that this transformation of district heating and cooling is very dynamic, but it's a long-term process, and it has quite some challenges, and it has high cost. Yeah, it's no doubt on that. It has to be financed. So the district heating will be one promising technology in that, and has to adapt to these requirements of DHC transformation. And we have to really work on the regulatory obstacles to solve them urgently and as soon as possible. At the present situation, we already see quite a demand for solar district heating. So in all these transformation plans which are made at the moment, we see very often solar district heating plans. That's quite nice. Many doors are open now, and we have to find pragmatic solutions and be fast in the development. Thanks for your attention, and I'm ready for your questions.
Thank you, Thomas. Very useful, very informative. Thank you very much. I'm also feeling slightly nostalgic for my days in Germany, seeing all those beautiful pictures of Germany in the sunshine. So thanks for that. Gets it out of the grey early spring days. So yes, we have question and answer session now. A number of you have very kindly put questions into the chat. There are quite a few sort of comments. Apologies, I'm going to skip them. It's not not very useful for us to read them out and make use of the speaker's time. I will stick to the questions that are related to the topic of the call as well, rather than more general topics about district heating in general or policy in general, for example. So let's start with one for Thomas as the last on the line. This one is, I'll read it out word for word, and we can interpret together. The rise of district heating of water using photovoltaic electricity to power elements in the hot water tanks of residential. What will this PV and solar hot water technology have on the future of fluid exchange systems, such as antifreeze and freon-based solar hot water or otherwise? I don't know if this is a little bit too technical for the audience today, or whether you want to get back to the question ask her at a different date, but if you can answer now, that'd be great.
Okay, I understood it's for me, the question. Yeah.
Yes, Thomas, yes.
Okay, I'm not sure if I completely got it. So the question is maybe whether it will be PV together with hot water tanks or a solar thermal being
Yes,
used.
I think it's a mixture of a question comparing PV and solar heating, and also the role of fluid exchange in the solar thermal side.
I think, well, this question is comes, of course, quite often, whether it will be PV or solar thermal in the future. I think it's important to develop both technologies, also in the heating sector. The question is in general a bit, is there a heat pump in the district heating system? Yeah, so if there's a heat pump operated in the district heating system, then of course it's good if part of the electricity used by the heat pump is also coming from PV. Yeah? But I also want to mention that also with this combination, it's only a share. So let's say electricity for the heat pump, let's say in the winter season, which is the main heating season, will not come from PV. It must come from other electrical sources, also renewable electrical sources. So yeah, to make it short, if there is a heat pump, of course you can consider to feed also with PV. In the other cases, I think solar thermal has a really great efficiency on harvesting really energy from a limited area we have usually. So the let's say the harvest per square meter is much higher, 3 or 4 times higher with solar thermal, and then it's more convenient to take solar thermal solutions. But maybe Magdalena also wants to add something to this point.
I think you explained it quite well.
Okay, thanks.
Thank you both. I received a question that just came into the chat. I will save that one for last. It's a very general, nice topic to end on. So I'll save that one until the end. In the meantime, slightly more detailed questions. This one is back to Andre. In the CO2 equivalent difference in comparing PV and solar thermal, are you also including the LCA of the actual panels?
Yes, the data that I got is LCA data.
Okay, well, that's very simple. Of the PV and the solar thermal panels themselves. So that...
For this resource exergy analysis guideline, I bought a lot of data from EcoInvent and adapted it to the systematic of resource exergy analysis. And to be consistent, I also bought CO2 factors from this database. And the interesting part maybe for some is that it's not only greenhouse gas emissions for a 100-year scale, but also for a 20-year scale, which is relevant for short-term, short-lived climate gases such as methane. So usually those technologies that emit high amounts of methane, such as natural gas technologies, are even worse on a 20-year scale in comparison. And that data is in there. So even if you don't use resource exergy analysis and just want to do a greenhouse gas emissions analysis, maybe some data can be used.
Great, thank you. There is a follow-up question, I mean, from a different attendee, but it's much more specific. So which type of solar collector would be more suitable for district heating networks based on the parameters that you considered? Would it be flat plate or evacuated tube?
It always depends very much. The interesting part is that in the end, we want to have 20 degrees hot water, right? So, or maybe 43 degrees when it's about hot water system. So the lower the temperature that the district heating system can cope with, the better it is usually. So there's not necessarily a need for high temperature collectors unless you have limitations in the pipe diameter and you want to reduce pumping power, because there's a kind of a balance. The problem is the pumping power increases significantly the lower the temperature gaps are between the temperatures needed and the temperatures provided, but it's pure exergy, the electricity used. On the other hand, the thermal energy from the solar collectors is not pure exergy. It has a certain exergy share, as we've seen, like 35% for 80 degrees heat. But if it's lower, it's even lower. And there is some kind of optimum that needs to be figured out by considering all components with the specific performance factors. And then you know the answer. There is no general answer. That's the point. That's why the analysis needs to be done. This is the same counts for heat pumps. The heat pump is not necessarily good if you operate it with cold power and it has a low COP because it produces 150 degrees for some kind of radiator that's based on steam. It's not a good technology. So the technology by itself is not necessarily good. It needs to be quantified, the benefits over existing ones and alternatives, and then can essentially decide well informed.
Thank you. Yes, as always, it's not the technology itself that's good or bad. It's the coupling of the technology to the application that makes sense or not. Let's see if we can find a question for Magda. Oh, now 1 second. Yes, this is also quite general, but what would you see, this is for Magdalena, what would you see as the most critical challenges towards the decarbonization in the market of solar district heating in the Stuttgart area?
I'm not sure I got you right. The most what?
What are the most critical challenges that need to be overcome?
Okay. Yeah, in the Stuttgart region, of course, maybe some of you know it, or the asker knows it. Maybe it's a very special location because the city is in a valley. So you have a lot of houses very nearby, and not so much space for areas for heat supply or heat production. And this is maybe one of the biggest challenges to find areas to produce the heat. And yes, I think that's it.
No, thank you. I mean, that makes sense. As knowing Stuttgart, yes, it's very similar. Now I live in Sheffield in the UK, which has a very similar geography, lots of valleys and hills. It's hard to find the area in the high conurbation area. I understand we have only a couple of minutes left, so I have a general question posed by one of the attendees, which I'd like to ask to all of you in turn. So given the excellent examples and clear benefits of solar thermal district heating in Germany and Europe, how do we get policymakers in the UK to implement this low carbon solution? What would be your advice to the UK? I'll start with Thomas.
Yeah, I think first we have to put maybe a light on the role of district heating. So the question is how to develop district heating in all the sectors we have seen before in Magdalena's presentation. So we have small district heating networks, for example, in rural areas for villages here developed. That's a quite nice tendency we see at the moment. At the beginning, they have been very often based on biogas plants where you can use the heat, but now it's often also the combination of biomass and solar thermal. So this is one part where you can develop district heating and cooling. Then we have a lot of smaller or mid-sized towns which do not have so far district heating and cooling. And there, let's say, it's good to really promote heat planning, as it is now obligatory in Germany. It's now every municipality has to do a heat plan, the larger ones until 2026, the smaller ones until 2028. So this is very often the first moment local politicians have to take care about heat. Yeah, because so far this was a private issue because everybody had his boiler in the house, but now it becomes a community topic. So how together we can solve heat supply in our cities? What are the resources we have? What do we have areas in the city which are dense enough where we can put heating networks? Who could do it here? Do we have, for example, a utility which is already active in this field and has some experience, or who can help us to get experience in this field? Yeah. These are at the moment, let's say, the points of development. And let me add the last one. In the bigger cities, you have already district heating and cooling, but there it's a lot the question how to extend and densify existing district heating and cooling. So that's again, that you have the operators, but you have to convince the citizens to connect and things like that. So let's say these are the points where we can develop district heating and cooling, and that's something which really is having a high dynamic at the moment in Germany through this policy. I mentioned that we have at the moment. We have 700 members at HEFW. 2 years ago it was 500, so we have 100 new members per year, and these are very often now, let's say, operators of smaller cities which have to really come into the field. So let's say promoting heat planning will bring forward district heating, and if district heating is developing, then you will have renewable district heating and solar district heating.
Thank you, Thomas. Very insightful. Andre, Magdalena, was anything you'd like to add on that UK orientated question? Yes, Andre.
So maybe just an addition, obviously without heat networks, there will be no solar thermal heat networks. So that's absolutely crucial to have that first. But I think the key component is political will to do what it takes to realize decarbonization and to ensure that the social costs, so that the community is also on board by, for example, thinking about compensation schemes for those somehow affected by this transformation. And if that is in place, obviously it has all available options accurately, realistically, in a systematic way. For example, with resource exergy analysis, but also at later stages, maybe with LCA and life cycle analysis in addition to that. And then identify the best options. And if solar comes out as the best options, really prioritize this. So prioritize the climate transformation before other things, maybe also increase public awareness so that people are on board and want that. And it's not against the people, because in Germany we've seen if the people are not on board, it's a big problem.
Yes, we did notice from across the water that it's not all rosy in Germany, but still very great work you're doing over there. Magda.
Yeah, just a short addition, not only to inform the citizens, but also maybe to share information so that citizens can start initiatives. and that not only the policymakers are informed, but also the citizens who are willing to engage themselves and to start initiatives which can start a bottom-up process for an energy transition towards district heating or solar district heating in energy communities, for example.
Okay, thank you.
May I add something? I'm very glad of about this comment of Magdalena, because I wanted to add this also. I think it must not be policy. Of course, it's good if we have a good political framework and everything is there's funding and subsidies and so on, but it can be also local groups or enterprises starting the process. And if we look at the Danish example, where we have all these district heatings in the hand of associations, citizen-owned associations, I think, yeah, it's the impulse can come from many sides. Must not be policy.
Thank you. Yes, as a resident of as a former resident of a UK district heating network that was run by a large company, there is a tension that comes when you're a local resident at loggerheads with a company running the local district heating network. So yeah, appreciate the community-based advice and approach. We have overrun on time, so I'm my apologies to all the questions we couldn't get to. Please do feel free to contact any of the speakers directly with your questions. And my thanks to the speakers for their time and preparation and expertise. It's very much appreciated. And of course, thanks to everyone who attended. All of you stuck right to the end. Thank you very much. I hope it was informative. I hope you've taken with you some great lessons learned, and we can progress this fantastic area of low carbon renewable heat technology and the transition that we're all going through. I think, Arabella, have you got anything to say to close out the session?
Yes, actually I do.
So
just let me know whenever.
Yes, from my side, I think that's it. Thank you.
Okay, cool. Well, thanks, George, and thank you to all the panelist speakers for the presentations also from ICES's side. I just want to close out the webinar with a few follow-up information for the audience. So yes, the webinar has been recorded, and also the presentations have already been submitted by the presenters, and both of these resources will be made available to you online, both on the IEA as well as the ICES homepages, and that's going to take us a few days, but then they will be ready there for you. Also, on the behalf of both ICES and IEA SHC, I want to again emphasize our upcoming conference to you. That's Eurosun 2024. It's the ICES and IEA SHC International Conference on Sustainable and Solar Energy for Buildings and Industry. So right up the alley of our webinar of today. It's going to take place in summer, actually, last week of August on the beautiful island of Cyprus. So if summer holidays in the sun and some solar content sound appealing, I would suggest you submit your abstract. Submission deadline for all abstracts is 25th of March. And just as you will see below, we even have one theme exclusively dedicated to solar and efficient districts. So I think everybody should keep an eye out for that conference. Again, submission deadline is the 25th of March. And then for our next event that I'd like to share with you before we all leave, we will be launching the ICES Online Solar Energy Museum in a few days. Looks like this. It's a virtual solar energy museum which is covering over 60+ years of solar history. And we have galleries on topics such as solar thermal development and applications, architecture, passive solar, PV technology, R&D and commercialization, off-grid and remote PV, concentrating solar thermal, growth of the grid-connected PV systems, as well as a room on the ICES history. So this event is going to come up on the 19th of March, so just in a few days from now. You can register online via our homepage. So you're all invited to take a stroll down with us on memory lane, but also it's a growing museum, so there's going to be a futures room also included in it. Yeah, so we all invite you to join us there as well. And with that, I think it's time for goodbyes and for thank yous. Thank you again for joining us. If you want to stay in touch with us, reach out to us at public.relations@ices.org, and you can follow us also on the usual channels. And with that, thank you, everybody. Have a good rest of your afternoon and talk soon. Bye.
Thank you. Bye-bye.
Thanks.